In this video, I'm going to show you how to calculate wildcard masks really fast. And this is something you need to know for the CCNA exam. For example, OSPF is a classless protocol, so it only supports wildcard masks. The other example is access controlless, and that's whether it's standard or extended. What I've got here is a topology with a layer 3 switch and some routers. I've also got these two VLANs, VLAN 10 and VLAN 11. VLAN 10 has a subnet mask of /24. And VLAN 11 has a subnet mask of /27. The /24 is quite easy to do. You just invert the zeros and it's quite easy to calculate. It would be 0000255. And that's for a subnet mask of 255.255.255.0. Problem is when you get to a /27, it gets a little bit more complex. So if you're doing the CCNA exam, this will show you how to configure a wildcard mask really fast. What I'm going to do is show you how to do the wildcard mask with this /27 subnet mask. So since all IP4 addresses have 32 bits, and that's comprised of 4 octets, all you do is subtract 27 from 32, and that'll give you 5 host bits. So with 5 host bits, you want to know what the number of host IP addresses are available. So 2 to the power of 5. And that's 2 times 2 times 2 times 2 times 2. And that equals 32. Now, if you were doing subnetting, you'd have to subtract the subnet address or network address and also the broadcast address. And that would give you 30 host IP addresses available that you can assign to a network interface. Here, this is a wildcard mask, so you only subtract 1. And the reason you do that is you just want to be 1 inside that bit boundary. And 32 is a bit boundary. So that'll give you 31. And there's your wildcard mask, 00031. And conversely, if you want to configure an IP address on an interface, you need to use a subnet mask. So a /27, that would be 8 plus 8 plus 8. Since /27 is the network bits, so you take the first 3 octets, and they're all 8 bits. That would be 255, 255, and 255. And that would leave you 3 bits for the 27. So what you need to do is calculate the number for the last octet. So what you do is write the binary numbers. And that's 1, 2, 4, 8, 16, 32, 64, and 128. And that corresponds to each bit position here. And that's for an octet. And here we're referring to the 4th octet. So what you do is, since it's the 3 bits, you start from the left and add 128, 64, and 32. And that gets you the 224. And there's your subnet mask with /27. And I've got another quick example. This is a /29. So what you do is you take the 32 bits of the IPv4 address, subtract 29, and that'll give you 3 host bits. 2 to the power 3, 2 times 2 times 2, that'll give you the 8, minus 1 is 7. So there's your wildcard mask for a /29, 0007. And also if you want to configure a subnet for a /29, so the first 3 octets would be 8 plus 8 plus 8, that's 24. And these are network bits, so you just add another 5. And that 5 is 5 subnet bits, so you start from the left and add 128, 64, 32, 16, and 8. And there you've got 248. And there's your subnet mask. So this is something to know for the CCNA exam when you're configuring OSPF or ACLs.